All right, welcome back to our favorite topic, fractions. This one's going to be dividing by fractions. And it's really not that bad once we learn some shortcuts. If you already know these shortcuts, you might want to sort of jump ahead and just kind of go straight to the answer. But I would recommend holding back a little bit and going through the process of finding out why these shortcuts work. We've talked a bit about changing division to multiplication and reciprocals and reciprocals of reciprocals and things like that. And we're going to put it all together here to come up with shortcuts. So if you already know the shortcut, then you kind of know where this is going. But let me show you how we get from what we have already talked about in chapter 1 and earlier in this chapter and so on to come up with shortcuts that make solving these problems a little bit easier. So let's start with this one. So what's 3/7 divided by 2? Well, remember back from chapter 1 that that division is just multiplication of a reciprocal. So 3/7, we'll change the division to multiplication. So times, instead of 2, the reciprocal of 2 would be 1/2. And what we learned from last section is now we can just multiply across. So it'll be 3 times 1 over 7 times 2. I don't see any shortcuts here. We can't do like 3 divided by 2 easily, or 1 divided by 7, or 3 divided by 7, or anything like that. So I think we're good to just say this is going to be 4 over, not 4, 3 over 14. And then we're good. All right, so what's the reciprocal of 2/3? Okay, so if you remember back from chapter 1, what does a reciprocal mean? And again, you might know the shortcut to this. You already might know the answer. But let's go with what we've learned about in this course so far. And that was the definition of reciprocal was we want to multiply a number times something to get back to 1, which is the identity. So let's say we're at 4. So 4 times what would give us 1? And what we found is that reciprocal is going to be, if we have any x, the reciprocal is going to be 1 over x. And so this would be 1/4, because if we multiply 4 times 1/4, we get 4 over 4, which would be 1. Okay, but how about with a fraction? Could we do the same thing, just 1 over 2 over 3? And yeah, that's one. There's actually 2 ways to solve this, so I'll do it a different way for each of these parts here. So we could just say 1 over 2/3. Well, how do you solve this? Well, we know that 2/3, well, it's going to have 1 over, that's going to stay the same. And 2/3 is the same thing as saying 2 times 1/3. We learned that. So we have 2 times 1/3, and we also know that the product of reciprocals, if we have something like 1/3 times 1/4, then we can combine them and say 1 over 3 times 4. We can do the same thing in reverse, because this is what we have right here, right? We have a product of reciprocals. So we can just split that up. We can say 1/2 times 1 over 1/3. And now look at this. What is this? This is a reciprocal of a reciprocal. And we know that that is going to be 3. So now we have 1/2 times 3. And that's going to be 3 over 2. So that's going to be our reciprocal. But look at this. So our fraction was 2/3, and the reciprocal was 3 over 2. Any similarities there? Looks like an upside down version of this. So let's see if that holds true. So let's see if A over B, see what the reciprocal of that is. And as promised, I'll show you the other way of doing it. So again, we know that the reciprocal is going to be something, so a number times something to get back to 1. So if we have A over B, we know that we have to times something to get back to 1. And so let's say that that's going to be a fraction. Let's say it's going to be m over n. So basically what we want to do is we want to find values for m and n so that the numerator is the same as the denominator. So what number could we use so that the numerator and the denominator would be the same? So let's see. Well, what if we used b over a, which is what we're kind of thinking if this was correct. What would happen if we did b over a. We multiply that. So if we did a over b times b over a, what would we come up with? Oh, not 8, a. Well, this would be a times b, and this would be b times a. And let's see, it's commutative, so we can swap the order. So let's call this AB, and this one A over B, AB. So AB over AB is going to be 1. So we did it. That is the reciprocal. So that means B over A was the reciprocal of A over B. So we confirmed that. All right, so knowing that, that's going to make some of these problems a lot easier going forward with dividing fractions. Okay, so what is 3 divided by 5/8? Well, we know that division is just multiplying the reciprocal, so 3 times. Now, what's the reciprocal of 5/8? Well, now we know that the reciprocal of 5/8 would be 8 over 5. And a couple different ways we can do this. We could break it down into steps. If you're still wanting to do it that way, we can say that 8/5 is the same thing as saying 8 times 1/5. So this would be 24 times 1/5, which would be 24/5. You could also skip these middle two steps and just say 3 times 8 would be 24/5 and be done with it. Okay, how about 2/7 divided by 9/5? So 2/7 times the reciprocal of 9/5 would be 5 over 9. Now we just multiply across. 2 times 5 and 7 times 9. And let's see, I don't see any shortcuts here. So it looks like this might just be 10 over 63. Also, there's a video here. Go check out this video and the link in the description. Okay, so 14/3 over -2 over 9. All right, well, this looks a little bit different, but really, it's kind of the same thing as the last problem. We have 14/3 divided by -2 over 9. So we can convert this to division. This is going to be, or to convert this to multiplication, it's going to be 14 over 3 times the reciprocal of 2 over 9 is going to be 9 over 2, but don't forget our negative sign. So -9/2. And once again, we can go and multiply across. So 14 times 9 over 3 times 2. Don't forget your negative sign. It's very easy, especially as you get into more complicated algebra. It's very, very easy to forget these negative signs. So make sure that you're carrying them all the way through the problem. All right, so now do we do 14 times 9 first? Or do we look for shortcuts? Let's go ahead and look for shortcuts. Well, I see 14 over 2, and I see 9 over 3. I know that multiplication is commutative, so let's go ahead and change the order of these. Let's keep 14 over 9, 14 times 9, that is, on top, over, now let's swap these two. Let's do 2 times 3. And if you want, you can break these up into 2 different fractions, so that's really clear. We can do 14 over 2 times 9 over 3. And that's going to be 7 times 3. 14 over 2 is 7. 9 over 3 is 3. And that'll be equal to, oh, what did we forget? The thing I said not to forget, this negative sign right here. Keep this negative sign. And so one of these needs to be negative. So we know that this whole thing is going to be negative. And so this whole thing is going to be negative. And so our answer will be -21. All right, careful with those negative signs. Okay, so 32 is 2/5 of what number? All right, first of all, let's see if we can figure out what they're asking for in this question. So 32 is usually means an equal sign. So let's say 32 is usually means an equal sign. 2/5 is just 2/5. Of, remember what of means? Of means multiplication of what number? Okay, so 2/5 times something is 32. Well, if you don't know how to solve a problem like this, maybe start with a simpler problem. So let's say it wasn't 2/5. Let's say we had 32 equals, let's say 4 times question mark. So 4 times what would be 32? We might know that 4 times 8 is 32, but, well, I mean, we don't really know 2/5 times what is 32. How else could we describe this one here? Yeah, 8 times 4 is 32, but to solve this, we can do it backwards. Instead of doing 4 times something to get to 32, we can say 32 divided by 4 is going to be equal to our something. And 32 divided by 4 is going to equal 8. We can do the same thing here. So 32 divided by 2/5 will give us what is missing here. So 32 divided by 2/5 is the same thing as saying 32 times 5/2. Okay, so we could do 32 times 5, but let's go ahead for right now. Let's go ahead and write it out, 32 times 5/2, because now you might recognize that this is the same thing as saying 32/2 times 5. We've done this before, where we have a number on one side of a fraction that we end up combining with the fraction and then popping out the other number on the other side. We did that in the last section. So we did that again here, because now we know that 32 divided by 2 is 16, and 16 times 5 is going to be 80. Much simpler problem. Okay, so word problem. So each panel of fencing material is 20³ feet long. How many panels do I need to build a 60-foot fence? All right, another problem where maybe you don't really know where to begin here. So maybe it might be easier to use a different number to make this easier. So let's say instead of 20³, let's say each panel of fencing material is 5 feet long. Then how many panels do you need to build a 60-foot fence? Well, you know that it's going to be 60 feet in the end. You know that each one is 5. So then how many do you need to get to 65? So 5 times what is 65? Or the same thing as 65. Why did I say 65? Not 65. 60. 60. 5 times what equals 60? And so then we find that 60 divided by 5 would be equal to 12. Okay, so that's how we would solve it if it was a nice simple number like 5. We end up just doing 60 divided by 5 to see how many panels we need. So now we can do the same thing. Let's go back and just clear this out. And now we know it's 20³, but it's going to be the same thing. So we have 20³ for each one. We know we want a total of 60 feet. Then how many panels do we need? So that's going to be the same thing as before. So 60 divided by 20³. And that'll be the same thing as saying 60 times 3/20. And you might already see the shortcut here. Let's go ahead and walk through it again. We have 60 times 3/20, which is going to be the same thing as 60/20 times 3. Well, 60/20 is just going to be 3. And 3 times 3 is going to be equal to 9. So it's 9 panels of fence that we need. And we can check that if you wanted to. We can say, what is 20/3 times 9? Because does that give us 60? Not 62. Does that give us 60? So let's check to see if it does. Well, let's see what 20 times 9 would be. I see a shortcut already. This would be the same thing as saying 9/3 times 20. And 9/3 is 3. 3 times 20. And that's equal to 60. So that looks good to me. And that's it for 4.3. So go ahead and do these 4.3 exercises, and I'll see you for the next section.